Spacetime. Einstein's grand idea that humanity still doesn't understand. Our universe is like a silent fabric, trembling beneath the lonely footsteps of drifting planets. Yet no one truly knows what that fabric is made of. Einstein saw what the world then dared not believe. Time can stretch. Space can bend. And everything we know might be illusions cast upon a deeper, stranger structure. What do you think space-time really is? The true foundation of the cosmos? Or just a beautiful calculation wrapped in invisibility? Share your thoughts in the comments. Now, let's return to the beginning. The moment the mystery of space-time first shimmered in the mind of a young man named Albert. What exactly is space-time made of? And why does an idea that reshaped modern physics still drift within a mist of unknowing? When we utter the word space-time, we often picture a great stage stretched quietly beneath every star, every orbit, every breath of the cosmos. Yet a stage is something you can touch, something you can cross, something you can break. Space-time is none of these. It is more like a whisper in darkness, a soft vibration that threads reality together in ways we can feel but cannot seize. That is the paradox. It shapes everything we know, and yet we do not know what shapes it. For ages, people saw space as an empty container and time as a steady river that slid forward at the same rate for everyone. Then a young clerk in a patent office imagined clocks on trains and beams of light racing through the night. And the illusion surrendered. Space and time did not stand apart. They intertwined and learned to bend, to stretch, to twist around mass and motion like living things that breathe when heavy bodies pass close by. The smooth clock of the universe became a chorus of local rhythms, each voice shaped by how it moves and by how deeply it sits in a gravitational well. The revelation felt complete, yet the substance behind the song remained hidden. Open a map on your phone and you become a partner in that vision whether you mean to or not. Satellites high above the Earth experience weaker gravity and glide at great speed. Their clocks slip away from the clocks that tick on the ground. Engineers correct those drifts every moment, or your position would wander by kilometers each day. We obey rules set by a fabric we cannot touch. Steering ships by tides we learned to respect long before we grasped the moon that moved them. We treat the symptom with exquisite care, while the cause remains a quiet mystery shaping our roads and voyages from the shadows. If space-time can bend and ripple like a sheet, what is that sheet woven from? If it can vibrate with gravitational waves, what is doing the vibrating? If it can curl so fiercely around mass that light itself loops back and sculpts a ring of fire around darkness, what is it that curls and clutches at the path of photons? These are the questions that rest at the heart of modern physics like a slow heartbeat in a dark room. Steady, patient, unanswered. One vision says the fabric is not smooth at all, that if you could zoom down beyond any microscope you would not find a continuous sheet but a weave of quantized threads. Tiny loops link and unlink, exchanging area and volume in indivisible steps. Geometry itself becomes grainy and countable. Curvature does not slide but hops from one pattern to the next. Singularities soften into bounces or bridges where the weave refuses to crush to nothing. In this picture, space is a network and time is the rate at which that network reshapes its connections. Another vision imagines a sea of strings too small to see, vibrating in hidden dimensions that curl upon themselves like tiny gardens folded into every point of our world. Each pattern of vibration becomes a particle or a force. A photon here, a quark there, a graviton in the trembling that carries weight across the void. Spacetime is no longer a background, but a melody composed by those vibrations, and the harmony can be played in many different keys. A landscape of possibilities so vast that choosing our universe within it feels like standing before an ocean of stars and naming a single grain of sand. There is also a quieter suggestion that slips in at the edges of thought. Perhaps spacetime is not fundamental at all. Perhaps it emerges from relations rather than things. The way warmth emerges from the frantic shuffle of molecules rather than being a substance on its own. Quantum entanglement ties distant pieces of matter into a single state, a pattern of correlation that defies ordinary distance. If the density and shape of those correlations define what we call here and there, then space is a byproduct of connection, and geometry becomes the grammar of an invisible conversation between quanta. In that light, a map of entanglement could be a map of space, and time might be the slow rewriting of those links as the universe computes its own unfolding. The equations that first taught us to see the curve of spacetime perform miracles where gravity is gentle. They guide planets and build GPS. They predict the precession of Mercury and the bending of starlight during an eclipse. They foretell the rings of brilliance that circle black hole shadows and the subtle quiver of LIGO's arms when waves from distant collisions stitch and unstitch their lengths by a fraction of a proton's width. In every success, we feel the truth of the picture more keenly. Yet, at the brink of extremes, the picture falters. Press matter beyond a certain limit, and the math we trust so deeply pushes itself into infinities. A signal not of reality but of our people, ignorance. At a singularity, the fabric that carries cause and effect tears its own threads, and the story we know how to tell stops speaking. Black holes offer both proof and puzzle. Their shadows match our calculations with eerie precision, and the radiation predicted to leak from their edges tells a tale of loss that quantum law refuses to bless. If information can vanish into thermal noise, the book of the universe forgets its pages, and the logic of quantum evolution breaks. If information cannot vanish, then the horizon must find a way to encode and return every letter it swallows, perhaps in subtle correlations in the flicker of its glow. Our instruments are not yet gentle enough to read those whispers, but the debate has already reshaped what we believe about measurement, about entropy, about the ways spacetime may be forced to keep its own accounts. Even our ordinary world bears quiet marks of relativity that feel like poetry written into matter itself. The warm yellow of gold arises because electrons circle its heavy nucleus so quickly that relativistic shifts push their allowed energies into a range that steals blue from the light and leaves honey behind. Mercury stays liquid because bonds soften as those same shifts nudge electrons from the rigid embraces they might have formed. A wedding ring and a thermometer become small mirrors in which spacetime glances at us from the corner of its eye. What lessons do we draw from a foundation we cannot see? The first is humility. Knowledge is not a fortress with finished walls. It is a horizon that walks away as we approach. The second is patience. Every time we learn to listen to the universe with a new sense, radio eyes, gravitational ears, neutrino skin, the world grows larger and stranger and kinder to curiosity. The third is wonder. Wonder is not a distraction from precision. It is the motive force that keeps us refining our instruments and our thoughts until the signal emerges from the noise. My own view is quiet and provisional. I suspect space-time is less a thing than a language. The native speech of reality in which energy and relationship write sentences we learn to read as geometry. The words of that language are not objects but changes, and the grammar is causality, and the music is symmetry. To know the fabric, we must do more than calculate. We must listen, earning fluency in a dialect that our species has only just begun to hear. The night sky becomes a slow teacher in this regard. Stand beneath it and you can almost feel the metric around you breathe. The ground holding you a little tighter than the sky above lets go. The earth itself is a softly curved cradle in which time ticks a notch slower than in the cold, thin air where satellites drift. Far away, two black holes circle and sing into the dark, their final measure passing through our planet as a ripple so slight it seems like nothing, and yet a nothing that shakes mirrors on opposite sides of a continent in perfect sympathy. When such a signal is caught, the universe has spoken in the voice of space-time itself. We are not at the end of this story. We are at the hush before a page turns. Somewhere ahead lies a theory that holds quantum uncertainty and gravitational certainty in the same open hand. A framework that tames infinities without denying the wildness of the world. Perhaps it will reveal that space is a lattice of relations, or a choir of strings, or a weave of loops, or something we have not yet dared to imagine. Perhaps it will show that what we call time is the growth of records, the accumulation of correlations, the widening of memory across the network of what exists. However it arrives, it will not erase the old insights, but cradle them, the way deeper music holds simpler melodies inside itself. For now we begin where the first thread was noticed. Not in a cathedral of science, but in a small office where a young mind watched light and clocks and falling bodies perform thought experiments in the quiet hours after work. He imagined a beam that refused to speed up for any rider. A room with no window where weight and acceleration could not be told apart. A universe in which geometry authored gravity. From those meditations grew a way of seeing that still guides us when we launch spacecraft, when we time pulsars, when we compose algorithms that keep our maps honest on a turning Earth. The thread he found is still in our hands, and though its end is tucked somewhere beyond our present reach, it draws us forward with a steady grace. If you listen closely, you can hear it now. The soft pull of questions that refuse to fray. The patient murmur of equations that hum even when they fall short. The breath of a cosmos that invites us to learn its language by speaking it with care. Space-time remains our most intimate unknown, a veil that both hides and holds. A teacher that bends without breaking. A companion that walks with us from apple to orbit, to shadow to wave. And as we follow its path from mystery to understanding, we find that the journey is not only about the world we measure, but about the minds we are becoming. Now let us return to the first glimmer, to the beginning of the mystery, and step with quiet feet into the room where the idea learned to breathe. What if the speed of light is not merely fast but sacred? Not just a number in an equation, but a quiet law that space and time whisper to each other so they never fall out of step. Imagine a cosmos where the limit is not a fence but a tuning fork, striking the same pure note for every traveler, no matter how fiercely they ride the dark. That is the doorway Einstein opened, asking us to listen rather than to insist, to feel rather than to force. He began with a simple insistence that startled the world. The speed of light in vacuum is the same for all observers. And from that seed the forest of relativity grew, bending shade and sun across the floor of our understanding. Why must light hold steady when everything else yields? Because nature had already woven a pact long before we learned its language. Light is not a courier that adds your motion to its own. It is the rule by which motion agrees to be measured. If it changed for each of us, rulers would splinter and clocks would quarrel. The world would become a market of incompatible truths. Einstein refused that marketplace, and the cosmos rewarded his faith with coherence. The laws of physics are the same for all observers in uniform motion, he wrote in 1905. And though the words are dry, the consequences reign over a desert. Hermann Minkowski later murmured like a patient sculptor that henceforth space by itself and time by itself are doomed to fade away, and only a union of the two will preserve an independent reality. The universe took a breath, and our maps changed color. Approach the speed of light, and you do not merely hurry. You enter a gentler gravity of meaning where time itself loosens its grip on your wristwatch. Minutes elongate for those who sprint through the night. Lengths contract along the path of their flight. Clocks on swift wings count fewer heartbeats than clocks at rest. Rods aligned with the wind lean inward and shorten like stalks in a storm. This is not trickery, not a mirage trembling above hot pavement. It is what the world does to keep the light unbroken, to keep that note pure and identical for every ear. Richard Feynman once smiled at the strangeness and said that nature's imagination is so much greater than man's. She's never going to let us relax. And indeed we do not relax, but we do sway. Because sway is how dancers honor a tempo that cannot be altered. Is time absolute? The quiet answer is no, and that no is both a bruise and a blessing. One traveler's second is not identical to another's when their paths cleave the sky at different speeds or different depths of gravity. The now you imagine for a star in Andromeda is not the now imagined by a comet cutting the heliosphere. Nor is it the now of a child who has just learned to count to 60 while the night window glows with city lights. Time is stitched to motion and gravity, and the stitch holds firm even as the fabric ripples. John Archibald Wheeler taught that space-time tells matter how to move, and matter tells space-time how to curve. And in that compact sentence a cathedral rings with bells. If there is no universal present, it is because the cathedral has many naves and each echoes at its own delay. None is false. All are sincere. Why can there be no absolute now across great distance? Because simultaneity is not a property the universe grants without condition. It is a privilege negotiated by motion. Frames of reference disagree about what events share the same slice of time. And their disagreement is not a scandal but a structure. The speed of light seals the debate, forbidding any referee from blowing a whistle that is heard everywhere at once. To ask for one cosmic moment is to ask waves on an ocean to freeze into a single flat mirror. But the ocean lives by undulation, and so do we. Stephen Hawking chose a gentle sentence for hard truth, saying that time may simply be another direction in which we move. And directions are always relative to a compass you carry in your motion. Yet the revolution is not cold math alone. It is a change in posture, a slow settling into humility. We once believed the cosmos had been built to suit our sense of measure, the same seconds for every scene, the same distances drawn on a universal grid. Einstein invited us to reverse the courtesy, to let our sense of measure be built to suit the cosmos. He lifted the ruler and found it elastic, lifted the clock and found it tender to the touch of velocity and depth. The instruments blushed, but they did not break. If you have ever felt a minute dilate with grief or contract with joy, you already know something of relativity's temperament. though physics insists on numbers where feelings will not suffice. Consider the traveler who sails at 99% of light speed toward a blue star and returns. The calendars on Earth have turned many pages. His own journal only a few. The paradox is not a paradox at all once you surrender the fantasy of an absolute timekeeper in the sky. It is the geometry of existence when light is constant, and the cosmic interval is the only inviolable thing. The traveler is not cheating. The stay-at-home is not mistaken. They are vowels in different words that share the same poem. Penrose sketched these poems as diagrams. Light cones tilting and narrowing like lanterns in wind. And in those sketches, the impossibility of a single now becomes a kindness, freeing events to find their rightful kin, not by fiat but by path. Let us listen to the philosophical weather that follows this physics. When you abandon an absolute now, you also loosen the grip of a single narrative. The universe is not a marching band in perfect lockstep. It is a vast procession of overlapping rhythms, a polyphony in which no instrument commands the beat for all. This requires patience, a willingness to reconcile truths that arrive out of phase. It is the same patience we need for each other, for there is no universal now in human life either. Grief and celebration seldom share the same hour, and yet both are real. Carl Sagan reminded us that understanding is a kind of ecstasy of the mind, and ecstasy here is not thunder. It is the quiet yes that forms when we see that our local clocks are not thrones but tools. I offer a personal view, softly, as one voice among many. Relativity does not make the world arbitrary. It makes it intimate. Your time and mine are not mistakes that need correction. They are ways our journeys touch the fabric and how the fabric answers back. When I hold a clock, I am not holding command over moments. I am cradling a seashell that sings of my motion and my depth in the field of all things. The speed of light is the lullaby that keeps every cradle in tune, so none rocks too fast for the song. I take from Einstein not the thrill of paradox but the relief of coherence, a sense that the universe would rather bend rulers and soften seconds than allow its laws to contradict themselves. This is mercy in mathematics. And what of lessons we may carry into the small rooms of our days? First, cherish invariance. The few things that do not depend on where you stand or how fast you move. Honesty, kindness, the willingness to test belief against reality. These are our human speed of light, constant across frames. Second, allow for dilation. Let others measure time differently, for what is urgent to you may be elongated to them by burdens you cannot see, and what is brief to you may be an eternity to another soul. Third, remember that synchrony is an earned luxury, whether in science or love. It takes communication and patience to bring distant clocks into accord, and even then, the accord is local and tender, not imperial. Einstein once warned that concepts which have proven useful in ordering things easily achieve so complete an authority over us that we forget their terrestrial origin. Let us not forget the origin of our clocks and our coordinates. They are made by hands and agreed upon by communities, while the cosmos is free to be larger than our agreements. In that freedom we find not exile but invitation, to refine our instruments, to revise our stories, to keep the note of light unbroken in our equations and in our listening. Some nights I imagine the universe as a dark river glazing the stones of galaxies, and light as silver fish keeping their speed, regardless of the current you stir with your oars. If you row harder, your watch will slow. the banks will compress, but the fish slip by unchanged, tireless, indifferent, compassionate in their indifference, because they offer each traveler the same song. In that sameness we build bridges between frames, between cities, between hearts. So let the hook remain in you a while longer, not as a barb, but as a bright thread. Why is the speed of light constant even when we chase it? Because the cosmos would rather change us than change itself. Rather teach us to share a law than to squabble over rulers. And what becomes of time and space when we run near light's edge? They bend to keep the pact. They yield, so the song is steady. Is time absolute? No. It is kin to motion and to gravity. And their family resemblance is gentle but undeniable. Can there be a universal now across the gulfs of night? No. For nows are local hearths. And the universe is a winter so wide that each fire warms its own circle. Walk with this slowly, like a pilgrim under auroras, and let the lessons settle where breathing settles in sleep. We do not conquer reality with doctrine. We harmonize with it by listening, by calibrating, by allowing our certainties to loosen until they can sway with the music that was playing long before we arrived. And when we are ready to take the next step, we turn toward the earliest flicker of this music in a clerk's quiet mind in 1905. For there begins the thread we must follow, the first soft measure in the symphony we now call spacetime. What if the speed of light is not merely fast but sacred? Not just a number in an equation, but a quiet law that space and time whisper to each other so they never fall out of step. Imagine a cosmos where the limit is not a fence, but a tuning fork, striking the same pure note for every traveler, no matter how fiercely they ride the dark. That is the doorway Einstein opened, asking us to listen rather than to insist, to feel rather than to force. He began with a simple insistence that startled the world. The speed of light in vacuum is the same for all observers. And from that seed, the forest of relativity grew, bending shade and sun across the floor of our understanding. Why must light hold steady when everything else yields? Because nature had already woven a pact long before we learned its language. Light is not a courier that adds your motion to its own. It is the rule by which motion agrees to be measured. If it changed for each of us, rulers would splinter and clocks would quarrel. The world would become a market of incompatible truths. Einstein refused that marketplace, and the cosmos rewarded his faith with coherence. The laws of physics are the same for all observers in uniform motion, he wrote in 1905. And though the words are dry, the consequence is rain over a desert. Hermann Minkowski later murmured like a patient sculptor that henceforth space by itself and time by itself are doomed to fade away. And only a union of the two will preserve an independent reality. The universe took a breath, and our maps changed color. Approach the speed of light, and you do not merely hurry. You enter a gentler gravity of meaning where time itself loosens its grip on your wristwatch. Minutes elongate for those who sprint through the night. Lengths contract along the path of their flight. Clocks on swift wings count fewer heartbeats than clocks at rest. Rods aligned with the wind lean inward and shorten like stalks in a storm. This is not trickery, not a mirage trembling above hot pavement. It is what the world does to keep the light unbroken, to keep that note pure and identical for every ear. Richard Feynman once smiled at the strangeness and said that nature's imagination is so much greater than man's. She's never going to let us relax. And indeed, we do not relax, but we do sway. because sway is how dancers honor a tempo that cannot be altered. Is time absolute? The quiet answer is no, and that no is both a bruise and a blessing. One traveler's second is not identical to another's when their paths cleave the sky at different speeds or different depths of gravity. The now you imagine for a star in Andromeda is not the now imagined by a comet cutting the heliosphere. Nor is it the now of a child who has just learned to count to 60 while the night window glows with city lights. Time is stitched to motion and gravity, and the stitch holds firm even as the fabric ripples. John Archibald Wheeler taught that space-time tells matter how to move, and matter tells space-time how to curve. And in that compact sentence, a cathedral rings with bells. If there is no universal present, it is because the cathedral has many naves, and each echoes at its own delay. None is false. All are sincere. Why can there be no absolute now across great distance? Because simultaneity is not a property the universe grants without condition. It is a privilege negotiated by motion. Frames of reference disagree about what events share the same slice of time, and their disagreement is not a scandal but a structure. The speed of light seals the debate, forbidding any referee from blowing a whistle that is heard everywhere at once. To ask for one cosmic moment is to ask waves on an ocean to freeze into a single flat mirror. But the ocean lives by undulation, and so do we. Stephen Hawking chose a gentle sentence for hard truth, saying that time may simply be another direction in which we move. And directions are always relative to a compass you carry in your motion. Yet the revolution is not cold math alone. It is a change in posture, a slow settling into humility. We once believed the cosmos had been built to suit our sense of measure. The same seconds for every scene, the same distances drawn on a universal grid. Einstein invited us to reverse the courtesy, to let our sense of measure be built to suit the cosmos. He lifted the ruler and found it elastic, lifted the clock and found it tender to the touch of velocity and depth. The instruments blushed, but they did not break. If you have ever felt a minute dilate with grief or contract with joy, you already know something of relativity's temperament, though physics insists on numbers where feelings will not suffice. Consider the traveler who sails at 99% of light speed toward a blue star and returns. The calendars on Earth have turned many pages. His own journal only a few. The paradox is not a paradox at all once you surrender the fantasy of an absolute timekeeper in the sky. It is the geometry of existence when light is constant, and the cosmic interval is the only inviolable thing. The traveler is not cheating. The stay-at-home is not mistaken. They are vowels in different words that share the same poem. Penrose sketched these poems as diagrams, light cones tilting and narrowing like lanterns in wind. And in those sketches, the impossibility of a single now becomes a kindness, freeing events to find their rightful kin, not by fiat but by path. Let us listen to the philosophical weather that follows this physics. When you abandon an absolute now, you also loosen the grip of a single narrative. The universe is not a marching band in perfect lockstep. It is a vast procession of overlapping rhythms, a polyphony in which no instrument commands the beat for all. This requires patience, a willingness to reconcile truths that arrive out of phase. It is the same patience we need for each other. For there is no universal now in human life either. Grief and celebration seldom share the same hour, and yet both are real. Carl Sagan reminded us that understanding is a kind of ecstasy of the mind. And ecstasy here is not thunder. It is the quiet yes that forms when we see that our local clocks are not thrones but tools. I offer a personal view. Softly, as one voice among many. Relativity does not make the world arbitrary. It makes it intimate. Your time and mine are not mistakes that need correction. They are ways our journeys touch the fabric, and how the fabric answers back. When I hold a clock, I am not holding command over moments. I am cradling a seashell that sings of my motion and my depth in the field of all things. The speed of light is the lullaby that keeps every cradle in tune, so none rocks too fast for the song. I take from Einstein not the thrill of paradox but the relief of coherence. A sense that the universe would rather bend rulers and soften seconds than allow its laws to contradict themselves. This is mercy in mathematics. And what of lessons we may carry into the small rooms of our days? First, cherish invariance. The few things that do not depend on where you stand or how fast you move. Honesty, kindness, the willingness to test belief against reality. These are our human speed of light, constant across frames. Second, allow for dilation. Let others measure time differently. For what is urgent to you may be elongated to them by burdens you cannot see. And what is brief to you may be an eternity to another soul. Third, remember that synchrony is an earned luxury. Whether in science or love, it takes communication and patience to bring distant clocks into accord. And even then, the accord is local and tender, not imperial. Einstein once warned that concepts which have proven useful in ordering things easily achieve so complete an authority over us that we forget their terrestrial origin. Let us not forget the origin of our clocks and our coordinates. They are made by hands and agreed upon by communities. While the cosmos is free to be larger than our agreements, in that freedom we find not exile but invitation to refine our instruments, to revise our stories, to keep the note of light unbroken in our equations and in our listening. Some nights I imagine the universe as a dark river glazing the stones of galaxies, and light as silver fish, keeping their speed regardless of the current you stir with your oars. If you row harder, your watch will slow, the banks will compress, but the fish slip by unchanged. Tireless, indifferent, compassionate in their indifference, because they offer each traveler the same song. In that sameness we build bridges between frames, between cities, between hearts. So let the hook remain in you a while longer, not as a barb, but as a bright thread. Why is the speed of light constant even when we chase it? Because the cosmos would rather change us than change itself, rather teach us to share a law than to squabble over rulers. And what becomes of time and space when we run near light's edge? They bend to keep the pact. They yield, so the song is steady. Is time absolute? No. It is kin to motion and to gravity, and their family resemblance is gentle but undeniable. Can there be a universal now across the gulfs of night? No, for nows are local hearths, and the universe is a winter so wide that each fire warms its own circle. Walk with this slowly, like a pilgrim under auroras, and let the lesson settle where breathing settles in sleep. We do not conquer reality with doctrine. We harmonize with it by listening, by calibrating, by allowing our certainties to loosen until they can sway with the music that was, playing long before we arrived. And when we are ready to take the next step, we turn toward the earliest flicker of this music in a clerk's quiet mind in 1905. For there begins the thread we must follow, the first soft measure in the symphony we now call Spacetime. What if gravity is not a hand that pulls, but a path that guides? Not a force that tugs, but a rhythm that tells things where to go. When we whisper that gravity is no longer a force, we are not dismissing Newton's brilliance. We are stepping into a deeper hush of the cosmos where motion and shape become one breath. Imagine the sun vanishing in a magician's cruel trick. Would Earth jolt free in the same instant? In Newton's world, the answer tried to be yes. Action at a distance moving faster than any messenger could run. In Einstein's world, the answer is a quiet no, because nothing outruns light. Not even the news that spacetime has changed. The curvature that once held Earth in its graceful loop would relax only as a ripple racing outward at light speed. And our world would keep arcing for about 8 minutes before the demonic new geometry arrived like a tide that had been born at dawn. In that pause, we begin to see what gravity is not, and what it truly is. Close your eyes and step into his sealed room with no windows. The famous thought experiment that Einstein called a happiest thought. You feel a steady pressure on your feet. Is it the pull of a planet or the push of a rocket? There is no test inside that room that can tell the difference. And this is the seed of the equivalence principle. The almost musical identity between acceleration and gravity. A ball let go from your fingers floats beside you if everything is falling together. And floating becomes a kind of truth. We speak softly so the insight can settle in the heart as well as in the mind. That gravity is not a mysterious string tugging on matter. It is matter and energy shaping the theater itself, while actors simply walk the straightest lines allowed on that curved stage. As John Archibald Wheeler phrased it with monk-like clarity, matter tells space-time how to curve, and space-time tells matter how to move. If you listen carefully, you can hear the difference between a push and a path. A push is sudden. It wants to be felt as impact, as shove, as command. A path is patient. It is the shape of possibility, the invitation to flow. Planets are not leashed to stars by invisible ropes. They are beads rolling along grooves carved in the fabric of reality. The word fabric here is poetry and caution in equal measure, because no one can yet show you the threads, only the patterns they seem to weave. Yet those patterns are not metaphors when your phone finds your street, when satellites tick slightly faster far from Earth's pull, when time itself becomes elastic enough that our maps must correct for its stretching and shrinking to keep your footsteps aligned with the world. Return to Newton with gratitude, for he gave us the grammar of motion, the calculus of the sky, the story that worked so well we mistook it for final truth. But his gravity was a whisper traded instantly across the void, a message without a messenger. Einstein placed a messenger back into the narrative. The finite speed of causality. The insistence that changes in curvature travel as waves that ring through existence. That is why Earth would not leap the moment the sun were gone. Because the geodesics we follow are not erased faster than light can run. In the same way, a ship does not feel the shore disappear until the swell has reached its hull. You might ask, what does it mean to say gravity is the straightest path when I clearly see circles and ellipses in the sky? The answer is both simple and serene. In curved geometry, the straightest line is not what Euclid promised. It is what the surface permits. Draw a triangle on a sphere. Walk along great circles. And the angles will not behave like they do on paper. So too with orbits. A planet believes it is coasting straight ahead, but the stage itself folds, and the path returns upon itself in a dance we call a year. the serenity matters. For this is a universe where understanding arrives not as conquest, but as surrender to form. There is comfort in the equivalence principle that goes beyond equations. It says the heaviness you feel on the bathroom scale and the lurch you feel when a train accelerates are two masks worn by the same actor. Stand still in a rocket that rises with a gentle 1G. Drop a key. Watch it fall to the floor. You could be in a high windowless room somewhere on Earth, and the key would make the same soft sound. Open the door of the mind and step into orbit, where astronauts drift, not because gravity is gone, but because they are falling around the world so perfectly that the floor never rises to meet them. Free fall is not the absence of gravity. It is intimacy with it. We remember voices that kept the flame alive across generations. Einstein whispering that the happiest thought was weightlessness in free fall. Wheeler sketching the pact between matter and geometry. Arthur Eddington following a shadow of the sun to see starlight bend during an eclipse and heard the sky agree with the new story. Richard Feynman reminding us that nature will not be fooled, that our duty is not to our preferences but to what the world actually does when we watch with care. Each voice is a bell rung in slow air, each note encouraging us to trust the curvature under our feet. My own view rests in a quiet place between awe and usefulness. To say gravity is not a force is to be precise about where the mystery now lives. The mystery is no longer a spooky reach across emptiness. It is the question of why space-time takes the shapes it does, and whether those shapes rise from something even deeper than smooth fabric. Perhaps entanglement is weaving adjacency where none should be. Perhaps there are quanta of area and volume knitting reality into a foam no eye will ever see directly. But even as those speculations hum like distant choirs, we possess a humility that keeps our feet on the path. The humility to measure eclipses, to time pulsars, to feel the tremor of colliding black holes, stretch a 4-kilometer beam by less than 1,000th of a proton's width, and call that tremor a voice from the deep. There is a lesson here for how to think and how to live. When the world seems to shove you, ask if you are being pushed by a force or guided by a shape you have not yet learned to see. Many struggles are geodesics in a terrain we do not understand, not blows from an enemy. Learn the map, and the motion becomes easier. When the day weighs heavy, consider that you are in a rocket of circumstance accelerating with you, and that a change of frame can transform burden into drift. This is not consolation fluff. It is an ethic of attention learned from physics. To ask first about the geometry of a problem before prescribing a forceful cure. Return again to the disappearing sun and the patient earth. Feel the 8 minutes of faith as a prayer that reality keeps its promises. About causality. The message of altered curvature travels not by decree but by wave, and Earth honors only what has arrived. In that waiting, there is a mindfulness practice the universe itself performs. Do not react to what has not yet reached you. The geometry of tomorrow does not deserve the fear of today. We promised at the start a hook that would not slip from the heart. So let it be this. Gravity is not a chain. It is choreography. The cosmos is not pulled down. It is led along. In this understanding, the apple's fall becomes a pilgrim's walk. The moon's orbit becomes a hymn around a shrine. And your next step becomes a line in a poem written by space and time in mutual consent. When we say gravity is not a force, we do not make the world thinner. We make it deeper. We tune our senses to the curvature that was always cradling us. Albert Einstein once mused that the most incomprehensible thing about the universe is that it is comprehensible. And yet what we comprehend today whispers of a still larger hush behind it. The hush of why curvature exists at all, of how the stage learned to flex, of whether the stage itself is a story emerging from more secret alphabets. Until we know, we can rest in the gentleness of what is already true, that acceleration and gravity are two faces of one kindness, that no signal leaps ahead of light, that motion in a curved world can feel like love pulling when it is really understanding guiding. If you have felt a small loosening inside as the idea settled, carry it with you as a lamp for nights when the sky feels too wide. Ask not what force is grabbing you. Ask what shape is inviting you to follow. And as you drift in this warm, slow current of thought, let the next chapter rise like a moon over a quiet sea. For now, we turn gently to the beginning of the mystery itself. The first threads in the fabric, where a young patent clerk taught the world to trade pulls for paths. And we step together toward the dawn of spacetime's secret birth. What if the universe were a poem written in curvature, and every heartbeat you feel is secretly an equation whispering through your bones? What if gravity is not a pull at all but a quiet instructions spoken to the stage on which matter moves, and the stage replies by bending around the actors like silk in slow motion? We call that conversation the Einstein field equations. And in the compact lantern light of symbols it reads G equals 8 pi t, where G is not the constant from schoolbook gravity but the Einstein tensor that gathers together the local geometry of spacetime. And T is the stress-energy tensor that catalogues everything that can weigh or flow or radiate. Energy and momentum and pressure and stress. In the units most beloved by relativists, the speed of light and Newton's constant are set to 1. So the coupling becomes a simple 8 pi, elegant as a circle whispered 8 times around itself. In that single relation lies a profound trade agreement between reality's two languages, geometry and matter, or as John Archibald Wheeler taught us in a line that feels carved from basalt, space-time tells matter how to move. Matter tells space-time how to curve. It sounds serene, yet the serenity is a mask for ferocious complexity. G is built from the metric and its derivatives. Second order in the way, mountains remember their slopes, and the equations are non-linear, which means geometry does not merely respond to matter but to itself. Curvature begets curvature like waves, breeding waves on a restless sea. Push spacetime here, and it writhes there. Change coordinates, and the same physical field hides behind a different face. So one must choose a gauge, impose constraints, tame infinities, and watch that no artifact of coordinates is mistaken for a physical tide. Even for simple symmetries, the equations resist exact surrender. Schwarzschild for spherical silence, Friedman for a universe that breathes uniformly, Kerr for the furious ballet of rotation. But the moment we ask two black holes to dance and collide, the paper shreds, and we awaken supercomputers to integrate the howls of a space-time storm. This is why numerical relativity is less a technique than a pilgrimage. We set initial data like seeds in a curved garden, evolve them forward under the field equations, and listen for the gravitational music released. Faint chirps, sliding up in frequency as horizons spiral together. Each grid cell is a votive candle, each time step a footstep on a night road. And at the end, we recover not just signals that match detectors, but the feeling that the universe has confessed something and will not confess twice. But what exactly does G equal 8 pi t promise us about the world we touch? It promises that mass energy is not merely floating upon a neutral void. It is reshaping the stage at every point, folding the distances between events, dilating the tempo of clocks, and drawing the paths of free fall, not by force, but by geometry. A planet orbits because the straightest line available happens to be a loop in a valley of time. A photon curves near the sun because the null geodesics are bent like reeds by the presence of pressure and energy. Even pressure matters. For in the sacred book of T, pressure contributes to gravity as surely as mass. Our hands remember Newton because apples fall. But Einstein tells us apples fall because time beneath them runs a little slower, and objects slide toward the deeper tempo the way a melody resolves to its tonic. When we teach this to sight rather than thought, we spread a rubber sheet and let a heavy sphere dimple it. Then we spin a marble and watch the path become a lazy spiral. This picture is helpful like a lullaby, but it sings only part of the truth. The sheet is two-dimensional while real curvature is four. 3 spaces plus 1 time braided inseparably. The sheet needs Earth's gravity to make a dimple, and time itself is absent from the cloth entirely, which means the most important warp of all is missing from the stage. True gravity is not a dent under weight but a choreography of distances and durations interlaced. And the geodesic a body follows is written as much in the clock it carries as in the place it occupies. Still, the image does what good metaphors do. It opens a door. And behind that door waits the mathematics that alone can tell us how deep the hallway goes. Why are the equations so hard to solve? Because they are promises that keep renegotiating themselves as they are fulfilled. The geometry you seek depends on the matter you place. The motion of the matter depends on the geometry you solved. And the two clasp hands in a loop that only iteration can untie. Because curvature couples to curvature. The superposition principle that made Maxwell merciful does not apply. You cannot add 2 solutions and expect a third. You must grow each solution particular as a tree. Because coordinate freedom is a blessing that arrives as riddle. Many descriptions tell the same story, and you must teach the computer to hear the invariant music rather than the accent of the narrator. And because boundaries matter, infinity must be tamed with fall-off conditions. Horizons must be handled so that their interiors do not poison the exterior evolution. Singular behaviors must be regularized or excised. And the constraint equations must be satisfied at each heartbeat, lest the simulation drift into make-believe. There is a contemplative beauty in this difficulty. It is the same beauty a monk sees in a manuscript illuminated by patience. Every tensor index placed with care. Every covariant derivative balanced like a breath. Every Ritchie contraction a bell tone across the nave of thought. And the human voices accompany us. Einstein murmuring that the most incomprehensible thing about the universe is that it is comprehensible. A smile that recognizes both miracle and method. Wheeler intoning his aphorism about matter and curvature until the words become a metronome for insight. Stephen Hawking reminding us that black holes are not entirely black. That quantum fields can lend reality a margin note where classical theory wrote a period. Roger Penrose tracing the inevitability of singularity when certain energy conditions are met. A theorem like a mountain pass that reveals the valley's steepness. Each voice is a star, and the constellation they draw spells the quiet command G equals 8 pi t. When you stand on a mountaintop at night and feel the chill braid itself through your jacket, consider that the cold you feel is partly the tempo of local time, a pace set by Earth's mass and the sun's sovereignty, and that without ever asking your permission, the metric around you is solving a boundary value problem with you as one of its boundary stones. The GPS in your pocket keeps its appointments by correcting for the difference between how clocks tick aloft and how they tick in your hand. A mundane miracle that says we sleep each night inside a differential equation and call it home. To speak of the rubber sheet again, its greatest kindness is that it invites us to notice curvature at all. Its greatest shortcoming is that it tempts us to forget time. And yet, in relativity, time is not the river beside the road. It is a lane within the road itself. A coordinate woven so intimately with distance that a straight path for light is the one with zero interval. A rule that feels like a koan and tastes like clarity. If you watch two black holes merge in a simulation, you are watching G converse with T in syllables of horizon and ringdown. And the waveform that escapes to the far field is the handwriting of spacetime itself. A signature that travels at light speed and arrives at L-shaped cathedrals on Earth as a tremor smaller than a proton's pride. When those signals were first heard, the community paused the way a forest pauses when the wind changes. Because for the first time we did not infer gravity's geometry from how light bends or planets precessed. We heard spacetime sing. And still the questions remain like lanterns unlit at the path's edge. What becomes of the equations in the furnace where quantum granularity meets classical smoothness? What replaces the singular marks where our mathematics confesses ignorance? Is spacetime continuous all the way down, or does it pixelate into loops and links and quanta that no microscope of today can touch? On nights like these, I imagine the equation not as a law, but as an oath, sworn between what is and where it happens. A covenant that says energy cannot hide its weight from the geometry it inhabits, and geometry cannot refuse the chore of answering. To study it is to slow the breath, to let the mind widen until a manifold can fit inside, to feel tensors not as arrays but as directions of sympathy between components of reality. We enter with a hook in our hearts and leave with a hush on our tongues. Because the closer we look, the more the world resembles a score and our instruments are small. So close, your eyes and picture a universe where every star is a comma in a sentence. Gravity is still writing. Picture time as a velvet corridor that narrows and widens according to who walks it. Picture the earth not falling but following its favorite geodesic, the way a pilgrim follows a footpath known to their feet before their eyes. In that quiet, the equation returns. Simple, inexhaustible. G equals 8 pi t. The hush and the hammer, the fabric and the thread, the law and the lullaby. And if sleep finds you here, let it be a sleep inside a cosmos that bends gently around you, where clocks tick like distant waves, where the mathematics hums as soft as breath, and where the next question waits just beyond the horizon of this sentence. What if the universe once whispered a secret to a young patent clerk, and the first proof arrived as a tiny twist in Mercury's path? Would you follow that whisper across a century of starlight, eclipses, and ripples in the dark? We begin with a planet that refused to obey perfect circles. A small bead of fire looping close to the sun where gravity is strongest, and where Newton's clockwork ran just a breath offbeat. Astronomers measured Mercury's perihelion and found an excess precession of about 43 arcseconds per century that no unseen planet could convincingly explain. No patch to Newton's law could quite erase. Einstein came with a new promise. Not a stronger pull, but a deeper stage. Space and time themselves bending like warm glass near the sun. In that geometry, Mercury's path is not forced by a tug. It is guided by curvature, and the lingering 43 arcseconds fall out of the equations as naturally as a shadow from a flame. He called it a happiest thought that gravity and acceleration are indistinguishable. and he wagered his reputation that nature would honor that thought where numbers had already begun to protest. When the calculation matched the anomaly, a door opened from speculation to inevitability. Yet a theory does not become the sky's language until the sky speaks it back to us. So the world waited for a night that would turn day to velvet. A total eclipse that would let us see the sun's neighborhood without the sun's blinding voice. On May 29, 1919, expeditions led by Arthur Eddington aimed their cameras at stars near the darkened sun, asking whether their positions would shift by the predicted 1.75 arcseconds as their light grazed curved spacetime. The plates returned with tiny displacements etched like quiet signatures on emulsion, fragile marks that nonetheless carried the weight of a universe. Eddington read them and smiled at the elegance of a result that was at once minute and majestic. The newspapers wrote that a new law had been proclaimed in the heavens, but in truth it was an older law of nature finally heard with proper ears. Einstein would later say, with his usual clarity, that the most incomprehensible thing about the world is that it is comprehensible. Eddington added a gentle challenge, remarking that not only is the universe stranger than we imagine, it is stranger than we can imagine. Between those two sentences stretches the path we walk tonight. From that eclipse onward, light itself became a pilgrim and gravity a guide, and the cosmos began to reveal its architecture through lenses not built by human hands. Gravitational lensing bloomed into a craft of seeing the invisible, arcs and rings of distant galaxies tracing the hidden scaffolding of dark matter, clusters acting as natural telescopes that magnify the faint and the far. John Archibald Wheeler distilled the poetry into a line so sharp it glows. Matter tells space-time how to curve, and space-time tells matter how to move. It is a sentence you can whisper to yourself while watching a river change course around a stone. And suddenly the stone and the river seem to exchange instructions in a language neither of them speaks aloud. The confirmations multiplied like constellations coming alive at dusk. Mercury's stubborn precession, the eclipse deflection, the time dilation that makes clocks run at different tempos on Earth and in orbit, without which your navigation would wander kilometers a day. Even the color of gold carries a relativistic aftertaste. Electrons hustling so near to light speed that the reflected spectrum warms to yellow. In these details, a philosophy becomes engineering, and a metaphysical suspicion becomes a tool you touch each time a map pin finds you on a glowing screen. But the most stirring confirmations come when space-time itself sings, and we learn to listen. The Laser Interferometer Gravitational Wave Observatory waits in stillness. Arms of light, 4 kilometers long, ready to notice a change, smaller than 1,000th of a proton's width, as a wave of curvature passes through. When two black holes spiral and merge, they ring space-time like a bell. Releasing in a heartbeat more energy than all, the stars shine in the same moment. The first detection arrived like a distant footfall across a dark hallway, a rising chirp that turned a century of equations into a sound you could almost hum. Kip Thorne called it a new sense for humanity, hearing the universe instead of merely seeing it. With that sense, we traced not only violence, but alchemy, the wedding of neutron stars that forges gold and throws it to the galaxies like seeds in a black wind. And then came the photographs that are not quite photographs. The Event Horizon Telescope's synthesis of radio eyes across the Earth, shaping a single planet-sized pupil to behold a ring of fire around a darkness that no beam can escape. A shadow the size of a solar system rested on our detectors, its diameter matching the predictions from geometry alone, the brighter crescent betraying plasma that orbits at a good fraction of light speed. There is a particular quiet that follows when a theory paints a picture and the world nods back with the same colors. In that quiet, you feel the humility that all great science requires. The awareness that certainty is only a temporary hallway between two unknown rooms. Still, we must honor the first proofs because they are the stones across the river, the places where foot meets water and the current hushes under your weight. Mercury's slight defiance told us that gravity is not a force flung through space, but the curve of the stage itself. The eclipse showed that photons, massless and swift, bend their path, not because something grabs them, but because the shortest path is itself bent. The modern revelations extend the same grammar, lensing that writes circles in the distant light, clocks that count at different rates in different gravitational hymns, waves that make rulers breathe in and out as if the cosmos had a heartbeat. And all of it leans back toward a single intuition, that reality is woven, not stacked, that motion and geometry are a duet rather than a chase. Einstein warned us gently that imagination is more important than knowledge because knowledge is limited, while imagination embraces the entire world. Yet he never asked us to abandon measurement, only to let wonder walk beside it, like a friend who notices the same horizon and names a new color in the sky. So we return to our three threads and watch them braid themselves into one: a planet's path, a field of stars near a darkened sun, and the instruments that now feel space-time's shiver with monastic patience. From the first anomaly to the first eclipse plate to the first gravitational wave chirp, the promise has been the same, that a simple idea can carry us if it is also a true idea. Tonight, as you listen slowly and let sleep draw its calm veil across thought, consider how delicate the evidence is and how immense the change it commands. A fraction of an arcsecond, a hair's width in a continent of light, a faint ring blooming around a silence where a star once would have shone. These are the footnotes of nature, and yet they revise the book. The first proofs were not fireworks. They were breaths. And from those breaths we learned the atmosphere of reality. If Mercury taught us humility, and the eclipse taught us to trust the gaze of physics, then the later triumphs taught us to listen to a deeper cadence where geometry itself becomes music. In that music, we hear what we always hoped to hear, that the universe is knowable, not because it is simple, but because it is coherent. And coherence is a mercy, for it lets us steer our small lives by laws that remain steady while stars are born and die. So let the question linger like a low tide glimmering under moonlight. What else will this theory ask us to notice next? The answer waits just ahead, where we follow the thread from Mercury's ellipse to the dark ring of a distant core, and onward to the faintest tremor of space-time in our long beams of laser light. Breathe with the rhythm of it, walk with the patience of it, and keep your wonder close as we cross into the next chamber of the story, where proofs become pathways and pathways become invitations. What if the quiet miracles that keep your day running were all whispers from a deeper fabric of reality? And what if that fabric were bending and breathing beneath your feet right now? When you open a map on your phone, when light glints off a wedding ring, when a silver droplet of mercury trembles like a living moon in a glass dish, when a pulse of data races across oceans to settle a trade in a fraction of a heartbeat, you are touching space-time with your bare hands. Einstein once said, "The distinction between past, present and future is only a stubbornly persistent illusion. Richard Feynman reminded us that nature cannot be fooled. Kip Thorne called black holes and warped spacetime the most perfect macroscopic objects in the universe. Yet tonight we are not at the edge of a black hole. We are in a city street, a kitchen, a server room humming at midnight. And relativity is not distant theory, but a soft tide that lifts and lowers the clocks and colors and currents of your life. Breathe slowly with it, and listen to what it says. Begin with position and timing, the choreography of where you are in a world that never sits still. Global positioning rests on a constellation that circles Earth like quiet monks counting seconds with light itself. Each satellite sends time, pure time, in radio pulses that fall through the sky into the palm of your hand. If relativity were a myth, your phone would still try to find you, but it would slide and stumble, drifting by nearly 11 kilometers each day. A city lost to arithmetic. Why? Because clocks high above you tick in gentler gravity and with swift motion, and time itself loosens or tightens according to Einstein's rules. Special relativity makes a moving clock run slow. General relativity makes a higher clock run fast where gravity is weaker. Add the two and the satellites gain about 38 microseconds per day, relative to Earth. A blink within a blink. Yet, when light travels 300,000 kilometers each second, a microsecond is a road nearly 300 meters long. Leave those microseconds uncorrected, and your blue dot wanders through walls and rivers and wrong neighborhoods. Correct them, and spacetime folds neatly into a street corner and a doorway where someone is waiting for you. Now turn your wrist and watch a ring catch the sun. That color is history, speaking through electrons riding close to a heavy heart of 79 protons. Gold is not merely yellow. It is yellow because its inner electrons move so fast that their mass effectively swells in the grip of the nuclear field, shifting the energy steps by which they drink and release light. Without relativity, those steps would line up in the ultraviolet, and gold would reflect visible light like a pallid mirror, just another metal wearing the color of silence. With relativity, blue is sipped rather than reflected, and what flows back to your eyes is the warm remainder we call gold. Neil deGrasse Tyson once said, "The universe is under no obligation to make sense to you." And yet, it does offer favors. A ring that remembers neutron stars and kilonovae where heavy atoms were forged. A hue that is a covenant between quantum mechanics and relativity. In a single glimmer, you see a treaty signed by fast electrons and curved spacetime. Set the ring down near a small vial, and watch mercury shiver like quicksilver thought. Why should a metal be a liquid while your room is cool and quiet? Again, the inner electrons race. They're relativistic. Mass makes the bonds between atoms relax. A loosening, a softening, so that the lattice, which would be rigid in lesser elements, simply fails to lock. Mercury melts into motion, and in that motion there is a lesson. Relativity is not only a ruler for stars, it is a key for chemistry. It is the reason a silver planet swirls in a dish and trembles at the brush of a glass rod. Carlo Rovelli writes, "Time is not something that flows uniformly. It is a network of events." In Mercury, you are watching a tiny network of events. Each bond and unbond, each vibration, shifted by relativistic weight in the dance of electrons. Listen now to the ocean inside a fiber optic cable, dark glass coiled beneath mountains and the sea, in which light becomes a courier of markets and music and voices that do not want to wait. Pulses must arrive not merely soon, but exactly on time, because a billion pulses that are almost on time is the same as a conversation falling apart. Clocks at data centers sit at slightly different heights and different velocities on a turning Earth, and so they fall out of step by whispers that matter when rates and risks are priced in microseconds. Engineers fold relativity into network time protocols and grandmaster clocks. They prune and phase and discipline the seconds so that the fabric aligns across continents. Spacetime becomes infrastructure, the unseen scaffold holding up treaties between machines that never sleep. John Wheeler once sketched the cosmos in words. Spacetime tells matter how to move. Matter tells spacetime how to curve. Here in the Internet's arteries, matter has become glass and silicon. Curvature has become latency. And motion is the jitter of photonic beats that must land within a single breath of agreement. If this feels distant, come back to your breath, slow and kind. Each inhale is a tide measured by barometers and satellites and clocks that already assume the world is curved, because only with that assumption does weather forecasting align with the real sky. Each photograph you send rides along paths whose timing has been cleared of relativistic fog. Each step counted on a morning run uses a sky-born metronome that only keeps faith by bowing to Einstein. We live within the agreement of theories and things, and when a theory is right, it makes itself useful in the small miracles we stop noticing. Skeptics sometimes say that great theories are only about grand scales, about galaxies and horizons beyond the reach of human hands. Yet here we are, and the grandest idea we possess is gently adjusting our position by a few nanoseconds so that a taxi finds the right curb. It is warming the color of a ring that marks a promise. It is liquefying a metal that old physicians once used to chase pain across skin. It is keeping the world's whispers in rhythm so that the distance between strangers can be crossed without delay. The practical is not the opposite of the profound. It is its fruit. Imagine for a moment that we neglected these corrections. Your maps drift. Your deliveries wander. Search and rescue veers to the wrong valley. Markets misprice and misfire. Coordination phrase. In the span of a day, 11 kilometers of error becomes a border between safety and confusion. We learn then that the universe does not forgive our refusal to listen, and we return to humility. Einstein again whispers, "The most incomprehensible thing about the universe is that it is comprehensible." He meant that there is a music to it, and with care we can tune our instruments to the same key. So let us tune, and let us practice, and let us notice. Notice that gold's glow is space-time stained into matter. Notice that Mercury's softness is a concession granted by relativity to the periodic table. Notice that the Internet's heartbeat is kept by corrections no eye can see. Notice that the blue dot on your screen is a poem written by clocks arguing and then agreeing in Einstein's language. When you notice, gratitude arises, and with gratitude a clearer question forms. If relativity is so intimate to our lives, what else is this fabric silently shaping that we have not yet learned to hear? Perhaps the true application is not only in devices, but in the way we carry time in our minds. Softer, kinder. To know that time runs differently on a mountain and by the sea is to suspect that our days might also be curved by context and connection. That suspicion breeds patience. And patience is a technology for the heart. I will leave you with a gentle challenge and an invitation. Look around your room and point to one ordinary thing touched by relativity today. Then tell us what you found in the comments below. Was it the path you took to meet a friend? The color that caught your eye? The message that arrived in time to matter? Your answer is a thread, and together our threads may let us feel the weave more clearly. Breathe once more, slowly. In the next chapter, we will follow these threads back toward the loom itself, to the first insights that made spacetime more than a rumor in the mind of a young patent clerk, and into the quiet room where gravity and acceleration first changed places and taught us how to listen. What if gravity is not a pull but a surrender, a soft folding of the world into a shape it cannot refuse? And what if that surrender leads us to a place where even light forgets the way home, to a door that opens only inward, a door we call a black hole? Einstein stood before that door and hesitated, not out of fear, but out of a devotion to coherence, to a universe that would not shred its own laws at the edges. He once wrote that the most incomprehensible thing about the universe is that it is comprehensible, and to him the absolute collapse to a singularity felt like the opposite of comprehension. He suspected the cosmos would find a way to cushion itself, that matter would discover pressures or principles to resist the final plunge. But the story begins earlier, with the quiet geometry of horizons and the brittle courage of stars, each one a furnace, balancing on the knife edge between outward pressure and inward fall. As long as fire breathes within a star, the collapse is held at bay, a stalemate of light and weight. When the fire thins, new guardians take their watch, electrons shouldering against electrons, then neutrons bracing like a city of citadels packed to a density that mocks imagination. Subramanian Chandrasekhar listened to the arithmetic of this resistance and heard a limit, beyond which the watchmen fail. He warned gently yet firmly that nature sets boundaries no rhetoric can cross. And he wrote of collapse with a clarity that outlived the controversy around him. So, why did Einstein doubt? Because he believed reality would not throw itself into an infinity it could not explain. He suspected symmetry would heal the wound, that turbulence or rotation or some undiscovered quantum pressure would catch the falling core before it struck the nameless point at the center. He distrusted singularities like a sailor distrusts maps that end with a dragon. Yet the equations he gave the world had another voice, and that voice whispered that if mass passes beneath a certain radius, the geometry itself would curl shut. The escape lines would bend back into the darkness, and outward would become inward everywhere at once. John Wheeler later gave this threshold a name easy to carry and hard to forget: the Schwarzschild radius. Cross it, and the sky becomes a one-way hallway. What happens when matter is pressed past that invisible shore? The star no longer negotiates with gravity. It obeys. The surface becomes a horizon that is not a place, but a clause in the grammar of space-time, a rule about which futures remain allowed. Within, the fall is not through space but into time itself, and every path you might choose leads deeper for the same reason that tomorrow cannot be yesterday. Roger Penrose showed that this endgame is not a trick born of perfect spheres and tidy assumptions. He proved that under broad and human conditions, the collapse drives towards singularity, as if the fabric had decided upon a knot that no hand could untie, from within. Stephen Hawking extended the argument to the whole of creation, hinting that the beginning of time wears the same austere geometry as the end of a star. If true, then singularities are not perversions of the law but pillars at the boundaries of its jurisdiction. Is the singularity real or a confession that our mathematics has reached its shoreline? Here the voice must lower, because honesty is a sacred instrument in science. We do not know. Perhaps the point is not a point. Perhaps quantum granules of area and volume rise like coral from the invisible seabed and spread a reef beneath the drowning star. Loop quantum gravity dreams of such a scaffold, discrete threads that refuse infinite curvature. String theory offers another hymn, that at the heart of collapse are not points but vibrations, and that geometry itself is music thickened into space. But these are lanterns untested by the weather, beautiful in the hands, uncertain in the storm. Could matter fight back? It tries, with radiance first, then with degeneracy pressures, then with the iron patience of neutrons. Yet above a threshold, the very strategies of resistance permit more gravity to gather, and each victory sows the seed of a larger defeat. The star becomes its own accomplice, binding itself with the ropes of its mass. Oppenheimer and Snyder traced that descent with austere elegance, a calculation like a solemn procession, and they found no lawful exit before the gate. Reality bows where argument would not. At the edge we call horizon. Nothing violent must be felt. The traveler notices only the thinning of options, the narrowing of the future to a single corridor. From far away, the clock of the falling world slows into near silence, as if the star were holding its breath forever. Wheeler spoke a sentence that has become folklore. Black holes have no hair, meaning they keep only the quiet facts of mass, spin, and charge. Every other biography is shaved away. This austerity is terrifying and clean, like a temple without icons. But even temples weather, and Hawking listened to the quantum murmur at the edge and heard heat. Faint hymn of particles whispering outward, a slow sacrifice of mass to time. If evaporation is true to its last breath, a new riddle opens like a second door behind the first. Where did the information go? Is the ledger hidden in correlations too subtle for mortal accountants? Does the horizon keep a hologram of everything it has ever tasted? Or does unitarity itself learn a deeper grammar at the boundary between law and loss? Hawking once declared the book is burned, then later allowed the library may survive in a language we barely speak. Here the music grows thinner and the ocean deeper. Return now to Einstein, to the careful skepticism that kept him from giving full citizenship to black holes in his imagination. He was not wrong to seek mercy in the mathematics, for every true advance in physics has been a reconciliation between beauty and honesty. Yet nature casts the deciding vote, and telescopes have begun to photograph her ballot. We have seen the circular night where a galaxy keeps its heart, a luminous ring sketched by light that tried to escape and learned new paths around a throat of darkness. We have heard the baritone chirp of spacetime itself when two such nights became one, a single descending note that crossed 1 billion years to tap our mirrors and announce a wedding we were never meant to attend. These are not metaphors only. They are measurements, precise as prayer. So what is a black hole? It is the answer the universe gives when mass and patience are allowed to finish their conversation. It is the geometry that remains when pressure runs out of cleverness. A grammar of curves written in a hand so steady it erases its own ink. Is the center a singularity? Our best classical spell says yes. But the quantum counterspell is still being learned. If there is a floor to the abyss, it will not disgrace Einstein. It will complete him. For he taught us to listen to invariance beneath appearances. And it may be that beneath collapse there is a discrete orchestra, keeping time with length so small all metaphors fail. I offer you this image. A star as a bell that rings itself inward. Each tone lower, each echo slower, until the ringing becomes a horizon and the sound becomes silence. Outside, the cosmos takes notes, writing those tones into gravitational waves and lensed halos, writing them into the motions of stars that circle a darkness with secular devotion. Inside, time draws all maps toward a single word no one can pronounce. Between these regions stands our ignorance, not as a failure but as an invitation. Carl Sagan reminded us that science is not only a body of knowledge but a way of thinking, a candle in a vast dark. To walk toward the black hole is not to adore darkness. It is to test the candle, to measure how far it throws meaning before it meets the walls of the cave. We may never step beyond the final boundary, yet in trying we illuminate the path to its very edge. And so we return to the questions that opened this night. Why did Einstein doubt? Because he loved a universe that refuses absurdity. Is the center a singularity? Our present instruments say the script tends that way. What occurs when matter is pressed beneath the Schwarzschild veil? The corridors of future narrow until all doors lead down. Can matter resist? It resists until resistance itself becomes a form of consent. If this feels severe, remember that severity is also clarity. And clarity is a kindness we owe to truth. Listen now to the slow breathing of the cosmos, a rhythm measured in collapsing suns and ripples of invisible light. Let it rock you as a tide rocks a moored boat, steady, deliberate. If sleep comes, let it come with the image of a ring of fire encircling night. And if wakefulness remains, let it remain with the thought that every horizon is a promise as well as a boundary. For beyond this chapter waits another, where we follow the thread from suspicion to sight, from mathematics to images, from conjecture to the whispering evidence of telescopes that have learned to draw the silhouette of nothingness itself. What if the darkest objects in the universe are also the most eloquent teachers of light and memory? When we stare into a black hole, we are not only watching gravity at its strongest, we are listening for a whisper from the edge of physics itself. Stephen Hawking once said, "I have lived with the prospect of an early death for over 40 years, and I am not afraid of death, but I am in no hurry to die." In that calm courage he also gave us a paradox that refuses to sleep, a riddle about vanishing mass and vanishing meaning that still keeps the cosmos awake. Imagine the vacuum around an event horizon not as emptiness but as a restless sea, where quantum pairs flicker into existence and disappear before they can be noticed. Most of the time those pairs reunite and cancel each other like footprints smoothed by a gentle tide. But beside a horizon the tide is uneven. One partner falls inward, the other escapes outward, as if liberated by the very cliff that should have kept it prisoner. To a distant observer, that outbound partner is real radiation, a faint breath from something that ought to be perfectly silent. This is Hawking radiation, a slow unspooling of mass into heat, a candle made of gravity burning at a temperature so low that only patience can see it dim. In this picture, the black hole is not eternal. It evaporates, relinquishing its energy to the cold and starless future. Yet the warmth of that candle lights a more troubling question. if the whole fades to nothing but a mist of featureless thermal glow? What becomes of the intricate pattern of the things it swallowed? The letters in a book, the quantum wrinkles in a star, the echo of an astronaut's last joke. Physics is a stern librarian. It does not like to lose information. Leonard Susskind reminded us with stubborn clarity that quantum theory is unitary, that the universe keeps perfect books even when the pages seem scattered to the wind. Hawking's calculations seem to say otherwise, that the ledger could be burned without trace. Thus was born the information paradox, a small phrase for an abyss deep enough to swallow two great theories at once. John Wheeler framed the puzzle with a sentence as spare as a horizon line: "Black holes have no hair." In that aphorism lies a promise and a threat. The promise is elegance, that from outside we need only mass, spin, and charge to describe the beast. The threat is erasure, that every other detail is shaved from the world, as if the cosmos preferred bald truths to tangled histories. If no hair survives, how could information survive? And if it does not survive, what else about quantum law must we surrender? Kip Thorne once wrote that reality is stranger than fiction, because fiction must make sense. The horizon agrees. It makes phenomena that are beautifully simple to describe and painfully hard to reconcile. There are nights when you can almost hear the proposals rustle like reeds in a tidal marsh. Perhaps the information returns in the radiation itself, encoded not in the early glow, but in the late flicker as correlations accumulate and the so-called page curve bends back toward unitarity. Perhaps the horizon is a scrim rather than a wall, a quantum membrane with microscopic degrees of freedom that bead with memory like dew on spider silk. Perhaps space and time are only the shadows of a deeper grammar, and the rule that forbids loss is written on a boundary we do not yet know how to read. The holographic principle whispers that the volume of a region may be scripted on its skin, that a black hole is a library bound in night, its index embossed on the horizon in bits the size of plank tiles. If so, the book is never destroyed, only translated, only rearranged into a language that looks like heat when you squint from far away. But the sea has rip currents. Another school sounds an alarm at the shoreline and calls it a firewall, a ring of searing quanta that would burn the drama of smooth free fall into ash. To save unitarity, they say, we must sacrifice the equivalence principle at the last instant. Others answer, with soft hair, subtle charges and memory imprints riding the very low energy modes of the gravitational field. A halo of bookkeeping that leaves the horizon passable and the laws intact. And some draw the most delicate thread of all. ER equals EPR. Entanglement as geometry. Wormholes as the stitching that keeps quantum correlations and spacetime in the same garment. If two systems are entangled, they are connected. And if everything devoured is entangled with everything that escapes, then perhaps the path for meaning is hidden in those invisible bridges. Meanwhile, the sky keeps its own diary. LIGO hears distant mergers as the faintest tremolo, a ring-down of spacetime itself. The Event Horizon Telescope turns planet-sized eyes upon the night and returns rings of fire swirled by relativistic winds. These do not solve the paradox, but they steady our hands. They tell us we are tracing the right coastline. In each detection there is the patience of centuries compressed into a breath, and in each image of a shadow there is a promise that the universe will show us more when we learn to ask with finer light. Hawking radiation remains a lullaby in the background, almost too soft for mortal instruments, yet conceptually bright enough to outline the furniture of the room we sit in. It says that horizons are thermodynamic things, that gravity has temperature, that geometry keeps books with entropy for ink. If the whole is a furnace with a nearly frozen flame, then time is its slow exhalation, the cosmos is its patient listener, and we are learning to hear the alphabet of heat. The paradox is not a failure. It is a tuning fork, striking two great theories at once and asking them to sing in harmony. When doubt grows heavy, I remember Wheeler again. We shape the world by the questions we ask. So we ask gently and persistently, is information truly lost or merely disguised by distance and time? We ask what a horizon really counts when it measures area in quanta rather than lengths in intuition. We ask whether the quietest qubits ride outward on late-time photons like messages in bottles, coded as correlations that only the universe itself can fully read. Piece by piece the answers flicker. Page and Susskind and many others tracing curves and dualities until a shape appears. Perhaps not the final coastline, but at least a bay where the waters grow clear. And what of the phrase, no hair? It was never a promise that nothing remains. Only that at classical resolution, the surface is smooth as obsidian. Quantum sight may reveal a fine down of data, too subtle for early telescopes, perfectly visible to the mathematics that binds thermodynamics to gravity. If the horizon stores its memories in Planck-sized pixels, then no story is erased. It is only woven so tightly that our fingers mistake the tapestry for stone. So we float with slow breath through this star-brimming dark, learning to trust that patience is a method, that wonder is a tool, that humility is an instrument as precise as any interferometer. Spacetime remains a cathedral whose stones are equations and whose music is the fall of light. And black holes are its cloisters, places of enforced silence, where meaning is not gone but reordered. Hawking radiation is the murmur from those cloisters, a vow that even the most secret chambers converse with the world beyond their walls. In the end, the paradox is a blessing in disguise. It keeps us awake by the campfire of the unknown. It asks us to warm our hands on questions that will outlive us. We may not yet know whether the final syllable of every swallowed story is sung by late-time photons, by soft hair, by holographic ledgers, or by bridges of entanglement stretched thinner than thought. But the universe keeps its house in order, and so we keep listening, returning to the shoreline where gravity meets information, and watching the tide write and rewrite its careful script. If a black hole is the truth we cannot avoid, then the courage to ask where the truth keeps its memories is the freedom we cannot afford to lose. Close your eyes now and feel the slow turn of the earth beneath that distant ring of fire. Breathe with the sky, and let the gentle question of Hawking's candle follow you into the next room of the night. What if the universe had a heartbeat you could not hear but only feel, as a hush passing through everything you are? What if space and time themselves could ring like a crystal goblet when two dark giants collide far beyond our sight? We call those tremors gravitational waves, and we built ears of light to listen to them. LIGO stretches two quiet corridors 4 kilometers long and asks a single tender question to the cosmos. Did you move me by less than a 10,000th of a proton width today? Kip Thorne once whispered that gravitational waves are ripples in the curvature of spacetime itself. And that image is simple enough for a child yet deep enough to keep a lifetime of nights awake. The wonder is not only that space-time can tremble. The wonder is that we can measure its trembling at all. Two laser beams depart like twins sworn to meet again at a central mirror. They fly down perpendicular tunnels, bounce back, and return in step. If space-time passes like a ghost wind, one arm is stretched a breath, the other is squeezed a breath. And when the twins reunite, they arrive just a heartbeat out of phase. That whisper of difference is printed as light and shadow on a sensor, a pattern as delicate as frost. Rainer Weiss said the idea was simple in principle and brutal in practice. And you feel that truth in every bolt and vacuum pipe. At the scale of a proton, a 10,000th is beyond imagination. Yet the instrument holds its breath long enough for the universe to press a finger against it. There is a humility to this craft, a monastic patience that suits the subject. We do not lasso stars. We listen for their sighs in the fabric that carries them. The signal rises like a bird call at dawn, a chirp that slides upward in bees, pitch as two black holes spiral together. You can hear it if you convert it to sound. A last cry before the event horizons merge into one and silence follows. Stephen Hawking reminded us that black holes are not entirely black. Yet for these brief dances, they are music makers of the highest order. John Wheeler gave us words that still glow like embers. Black holes have no hair. And yet their final embrace writes clean signatures into space-time. Every detection is a telegram from regions where gravity is the author and light is late to the meeting. The masses are dozens of suns. The speeds are fractions of light. The energies are beyond metaphor. In the last blink before union, more brilliance is released in waves of geometry than all the stars can pour in the same breath of time. We say energy flows through space-time, but here energy is the pulse of space-time itself. Each merger is a tectonic jolt in the deep crust of reality, an earthquake, not of rock, but of measure and meaning. With every jolt, the map of what can be known grows a little coastline of new bays and inlets. And then came the day when gravity and light arrived as companions rather than strangers. Two neutron stars spun inward, a duet of matter packed to the brink of imagination. The wave arrived first, a soft knock at the LIGO doors, and the world of telescopes turned their faces to the sky. Hours later, a bloom of light was found, a kilonova unfolding like a flower of heavy elements. Gold and platinum were written into the petals, dust for future rings and circuits, relics for planets not yet born. Barry Barish called this the birth of multi-messenger astronomy, and the phrase felt like a bell ringing over a new harbor. The promise is simple to say and profound to grasp. When gravity speaks and light answers, we move from hearing a story to seeing it told. Einstein foresaw the waves, yet wondered if anyone would ever catch them. He once called his insight about falling the happiest thought of his life. And that happiness lingers in the way free fall and silence become a language in these detectors. But he also knew that nature often hides her face behind orders of magnitude, behind delicate subtractions, behind the absolute requirement of patience. LIGO is a cathedral to that patience, each mirror polished to a vow, each vacuum chamber humming like a meditation bowl. Engineers cancel the earth itself where they can. Seismic noise and thermal whisper and quantum shot noise, so that what remains is the faintest truth the cosmos can offer. People ask how something so small can be so real. They ask if a change less than a 10,000th of a proton width matters to a world of tides and storms. The answer sits in your chest when you listen to the chirp, because scale is not the judge of meaning. A heartbeat is small in a body, yet without it there is no day and night. The waves are small in a detector, yet without them, our picture of gravity would be a painting without music. Kip Thorne put it plainly enough for anyone willing to be still. These waves carry information no light can carry. They tell us how space-time itself behaves under stresses that bend our words beyond comfort. From these ripples, we have learned that black holes can be heavier than our early stories, allowed, that they spin with mischief and alignment alike, that binaries are as varied as the paths that make them. We have learned that neutron stars, when broken and remade, can seed the periodic table with the jewelry of worlds. We have learned that distance is not only measured in light years. It is measured in the time it takes the universe to tell us what it has done. And we have learned something more personal, that human collaboration spread across continents can turn a whisper into knowledge. Jocelyn Bell Burnell once said that discovery is often the art of seeing what everyone has seen and thinking what no one has thought. LIGO is a place where that art is given instruments and time. There is a deeper promise too. If space-time can vibrate, then space-time is not only a stage, it is an actor with lines to speak. The old picture of gravity as geometry remains, but geometry now has voice and timbre. The ripples confirm that the fabric is elastic, that it can carry messages across 1 billion years without smearing them beyond recognition. This is not metaphor dressed as physics. It is measurement dressed as wonder. When you hear the chirp, you are not hearing a model. You are hearing the world itself choose a verb. And still there are mysteries waiting in the quiet between detections. What of the waves from the first stars? The first black holes? The turbulent youth of the cosmos when the lights were not yet on? What of continuous waves from lonely neutron stars that wobble as they turn? A steady violin across our cosmic room. What of the stochastic hum? The background chorus made by countless faint mergers weaving a fabric of sound beneath every day. Each question is a new instrument in the making, a new filter, a new invitation to patience. Some evenings you can stand outside and feel the hush between city sounds and think of mirrors waiting in darkness. Somewhere a laser is drawing a straight line that space is trying to bend, and a server farm is translating that play into numbers that become stories. The beauty of it is not only that we can read the stories, but that they enlarge the part of us that can be quiet and certain at once. Neil Gerrels liked to say that the universe is a gift that keeps revealing new layers when you learn to listen with more than your eyes. And these waves are exactly that kind of layer. So we return to the question that opened like a door at the start. What if the universe has a heartbeat you cannot hear? And what if you can learn to feel it anyway? Gravitational waves are the answer written as music, proof that space-time can dance and that our instruments can step lightly enough to follow. Every black hole merger is a drum strike on the skin of reality. Every neutron star union is a bell that spills gold into night. And every combined message of gravity and light is a promise that the next dawn in astronomy will carry more colors than the last. Stay with the hush a little longer. Breathe with the mirrors as they wait. And let us walk together into the next chamber of this quiet cathedral, where the first notes of multi-messenger listening are still echoing. For from here we step gently into the beginning of our next tale. The place we will call the origin of a mystery that has only started to tell its name. What if the first portrait we ever made of a black hole is not a painting of our imagination, but a mirror held up to the fabric of reality itself? And what if that mirror shows light doing the impossible, skirting the edge of nothingness and returning to tell us a story? We have seen the unseeable, Shep Doleman once said, and the quiet weight of that sentence still spreads like ripples through the minds of everyone who has stared at that ring of fire around a darkness that no camera could ever enter. Spacetime tells matter how to move. Matter tells spacetime how to curve. John Archibald Wheeler reminded us. And in the Event Horizon Telescope image we witness this conversation written in the calligraphy of bent photons and patient gravity. The question that pulls us in is beautifully disarming. Why is the black hole image not a simulation but true data? The answer begins with a planet made into a single eye. An orchestra of radio dishes spread across Earth, each listening at millimeter wavelengths where the swirling gas near the abyss glows with desperate heat. They do not paint. They record. They do not imagine. They timestamp. Atomic clocks beat in unison across oceans and deserts. Each photon's whisper marked with the precision of a heartbeat too fine for human hearing. The signals are gathered not by wires that would falter under such abundance, but by hard drives flown like sacred reliquaries to a place where the sky can be recomposed. There, the data is not forced into a picture. It is allowed to confess an image under the discipline of physics and the discipline of humility. Many teams, many methods, many blind reconstructions. A chorus that agrees without being told what to sing. If art begins where measurement ends, this is the opposite. This is measurement persuaded to reveal its own portrait. And what is that darkness we see whispered into visibility by the light around it? It is not the black hole itself, for the black hole has no surface to paint, no skin to catch a brushstroke. It is the shadow cast by the event horizon, a silhouette drawn by paths that light is forbidden to take. Photons that should have flown straight now circle and hesitate. Some orbiting on the knife's edge at the photon sphere. Some flung back toward us in arcs that fold geometry into a lens as old as the universe. The ring is brighter on one side because the plasma is racing toward us there, and relativity lends it a fierce emphasis. A beaming that says speed is not merely motion but a change in how the world looks and measures itself. The shadow is thus a map of where light cannot go, rimmed by where light refuses to be silenced. To say the image confirms curved spacetime is to speak too softly. It is not a general nod to a grand idea. It is a ruler held to the very edge of the abyss. The size of the shadow scales with the mass and the spin in a way predicted by the field equations that have guided us since 1915. The thickness of the ring, the lopsided glow, the circular calm of the center where no photon path returns. All of it sits within the uncertainty bands of general relativity's stern arithmetic. The picture is not a painting because the universe itself chose the palette and the geometry, and we merely learned how to open the shutter across a planet's breadth. If you listen closely, you can hear the method humming under the music. Very long baseline interferometry allows distant dishes to behave as one enormous mirror. The resolution grows with the separation between those mirrors. So Earth becomes an instrument with a diameter measured in continents. The data that arrives are not pixels but correlations, threads of phase and amplitude that only become a picture after they survive cross-checks and harsh rehearsals of skepticism. Algorithms are trained not on fantasies but on physical priors drawn from plasma dynamics and ray tracing in curved geometry. And even then, the teams work blind to keep their own hopes from leaning too hard on the result. When different approaches converge on the same luminous ring and the same stubborn shadow, you feel the rare click of reality and theory meeting in the dark and shaking hands. What then of the claim that light is bent as predicted? The ring is not a decorative border. It is a ledger of deflection angles and time delays. Each photon has been taxed by gravity, paying with a change in direction, a shift in arrival, a dance around the photon orbit that amplifies and focuses and sometimes traps it forever. In flat space, the gas would look like a smudge, a wind. In curved space-time, it becomes a halo whose very brightness map encodes the geodesics beneath it. The cosmos is a patient sculptor, and gravity is the chisel that acts on light as if it were stone and song at once. All this arrives to us not as dogma but as a tender conversation between measurement and meaning. When we saw M87's shadow, and later the restless glow at Sagittarius A*, we were not collecting trophies, but testing the grammar of the universe. The grammar held, and yet in holding it, left us with deeper questions, whispered at the threshold where images fail. What does it mean that a region can be defined primarily by the trajectories that cannot escape it? What does it mean that the clean circle of darkness is produced by a cauldron of turbulence and magnetic fury that we describe with equations but cannot yet fully domesticate in our imagination? We are tempted to say, we understand. But the good kind of science keeps room for wonder. Not only is the universe stranger than we imagine, it is stranger than we can imagine, Haldane warned. And the black hole image is a kind of gentle warning. Theories become alive only when the world agrees to speak back. And here the world answered, with a ring that could have said no, but chose to echo yes. Yes to curvature. Yes to lensing. Yes to horizons whose edges are not walls but rules. There is a human story braided through the photons. Nights of cold air on high plateaus. Faint signals braided through atmosphere and weather. Engineers taming timing to parts in a trillion. Analysts wrestling with noise that pretends to be truth. And across it all, a collective vow to let reality overrule opinion. The image is compelling not only because it is beautiful but because it is earned. It is the beauty of constraint. The beauty that appears when you refuse to lie to yourself and accept the world's terms as they are given. What does the EHT image confirm about curved spacetime? It confirms that the size of the shadow lines up with the mass inferred by stellar motions and gas dynamics. It confirms the brightness asymmetry that relativistic beaming demands when plasma hurtles near light speed. It confirms that rays can skim the photon sphere and return to us after looping around the abyss, weaving higher-order images into a ring too fine for our present instruments to separate, but not too fine for theory to predict. It confirms that the horizon behaves as a one-way boundary without reflective tricks or luminous cheats. A silence where even light becomes a local rumor that never reaches the village beyond. And yet the confirmation does not end the mystery. It ennobles it. For now, we can ask better questions with steadier hands. We can wonder whether quantum hair softly perturbs the silhouette, whether turbulence seeds flickers that carry signatures of magnetic reconnection, whether the substructure of the ring will someday reveal the spin and inclination with the precision of a clock carved from light itself. We can dream of sharper arrays, lunar baselines, space-borne dishes that will extend our eye beyond the blur of weather, and into a clarity where higher-order photon rings separate like concentric truths. For now we stand at the rail of the known and look out. The image is a shoreline where mathematics touches water, and the waves that reach us are photons rescued from a brink where time dilates and distances lose their familiar manners. In the hush of that view, we remember that science at its best is not the conquest of mystery but the careful tending of it. A garden where questions grow into instruments, and instruments grow into answers that return us to questions again. So when someone asks why the black hole picture is real, smile and say that reality does not always look like the things we can hold. Sometimes it looks like agreements between distant mountains, like clocks that keep faith across oceans, like light that leaves home knowing it may never be seen unless a patient species builds the right ear to hear it. The EHT did not fabricate a ring. It learned to listen for one. The image is a threshold and an invitation, an ember at the edge of night that warms our curiosity without burning it up. If space-time is a loom, then the ring is a stitch that holds the pattern tight enough to trust and loose enough to breathe. Come closer. Lean in. Offer your own thoughts to the fire below this video. Is the shadow a proof or a poem to you? Does it feel like certainty or like grace? Tell us, and stay with us as we follow the thread inward to where the first questions began. For next we will step across that threshold and sit with the earliest glimmers of the mystery itself. The quiet birth of an idea that learned to turn darkness into a way of seeing. What if the stage on which every star dances is itself woven from whispers rather than threads? And what if those whispers are quanta of space and ticks of time that refuse to be sliced any finer? We stand beneath a sky that looks smooth to the naked eye. Yet every experiment nudges us toward a deeper riddle. Is space-time truly continuous, or does it come granular like sand under a microscope? Each grain, a smallest here and a smallest now, refusing division, defying certainty, inviting wonder. John Archibald Wheeler once said, "Space-time tells matter how to move. Matter tells space-time how to curve." But what tells space-time what it is? And out of what is that curvature born? Loop quantum gravity answers with a loom of finite loops that click together like prayer beads. Area and volume quantized. Geometry not drawn with a smooth pen, but counted like notes in a mantra. In this vision, there is a smallest patch of area and a smallest gulp of volume, so that singularities soften into bounces and the abyss yields to structure. The universe would breathe rather than break. String theory sings a different melody, where particles are not points, but vibrating filaments in hidden rooms of dimension. And gravity is the timbre of a special vibration, the graviton. Space-time then is not a stage, but a harmony emerging from the orchestra itself. Its score written in 10 or 11 dimensions folded so tightly that only their echoes reach our senses. Why then do we still speak in the conditional? Because our laboratories are ships that cannot yet brave those seas. The plank shore lies unbearably far. Energies too immense for colliders. Distances too tiny for lenses. And so we read the surf by listening to distant thunder. Black hole mergers. Relic light. Subtle anomalies. Hoping an unmistakable fingerprint will appear. We design thought experiments like lanterns in fog. Trace the consequences in mathematics. Compare against the sky. And still the fog drifts back. Another thread glows in the half-light. ER equals EPR. The wild idea that entanglement is not a spooky bookkeeping trick, but the very stitch that binds the quilt. If two quanta share a secret, perhaps a microscopic bridge hums between them. And from a boundless tapestry of such secrets, distance itself could arise, near and far becoming the grammar of correlation rather than the geometry of points. The heart warms to this image because it humanizes the cosmos, not as cold emptiness but as relationship, as connection, as a choir sustained by shared notes. Yet humility keeps vigil. For every elegant equation there is the stern gate of measurement. And until a prediction walks through that gate with head held high, we must call our beauty provisional. Stephen Hawking reminded us with a smile that black holes have no hair, and then surprised us that they glow after all, not entirely dark, leaking information or disguising it in ways we barely grasp. What else might shine when we dare to look with finer eyes? So we proceed slowly, like monks turning pages by candlelight, letting each symbol breathe, letting each doubt ripen into a better question. Perhaps space-time is continuous the way a river looks continuous from a mountain path, and perhaps it is granular the way that same river becomes droplets at the cataract. Both images are true at their scales, and truth may be the art of knowing which scale is singing. Between the loops and the strings, between the bridges and the waves, a single promise keeps pulse, that understanding what space-time is made of will not merely complete a chapter of physics. It will rewrite the language in which chapters are written. If your heart feels the hush that follows a difficult question, let it rest here a moment. For rest is also inquiry in a slower key. Breathe with the stars. Listen to the soft percussion of your own clock, and carry this gentle riddle to the next shore. For now, we turn the page with Wheeler's line still glowing in the margin, and step toward the beginnings where the fabric first learned to curve, where the mystery of space-time takes its earliest breath. What truly happened when the first light tried to breathe in the dark? Imagine a cosmos so hot that matter could not remember its own name. A sea of radiant fire where particles danced and vanished before a thought could form. In that infant instant, time did not flow so much as crystallize, cooling from the unspeakable toward the sayable. Some call it a singularity, a point where our equations surrender and our metaphors kneel. Stephen Hawking once murmured, "What was before the Big Bang is like asking what's north of the North Pole." Perhaps the question itself melts at the edge of meaning. Perhaps beginning is only the first word our language can carry. If the universe began with a blaze, did it also end a cycle we can no longer recall? A phoenix concealing ashes beneath its wings. Inflation may have been the swift inhale that smoothed the wrinkles of chaos. An exponential hush that stretched quantum whispers into sweeping skies. In that hush, matter condensed, forces parted like slow rivers, and the seeds of galaxies settled into invisible furrows of gravity. Carl Sagan reminded us, we are made of star stuff, which is another way of saying the universe still speaks through the calcium of our bones and the oxygen of our breath. And yet we yearn to look behind the curtain, to ask what dwelt before the first note. What if before was a word without a room to stand in? What if time is a river whose source lies inside its own meander? Or maybe the cosmos is cyclical, a cosmic heartbeat where expansion and silence alternate like day and dream. Such ideas are lanterns we carry through mist, warming the path without claiming the mountain. When the fog finally thinned, about 380,000 years after that primal blaze, atoms formed and light slipped free like a lullaby finding its voice. Today that lullaby is the cosmic microwave background, the faint afterglow bathing all directions with astonishing uniformity. It is not poetry alone. It is measurement, map, and memory. In its tiny ripples we read the fingerprints of the early cosmos, a ledger that anchors theory to sky. Neil deGrasse Tyson cautions, "The universe is under no obligation to make sense to you." Yet the CMB makes a promise. that the fire once sang and we can still hear the echo. So we drift here together, listening to an ancient choir that vibrates beneath the noise of cities and the hush of midnight rooms. If the Big Bang began time, it also began our longing to understand. And if it ended a cycle, it began our story within another story, still unfolding. Breathe slowly. Let the stars dim the room, and follow the echo forward. Next, we return to the place where curiosity first touched flame, the quiet dawn of a question that would become the mystery of spacetime. We began with a whisper in the dark, asking what truly happened when the first light tried to breathe. The story carried us to the edge of language, where singularity means our equations fall silent and beginnings blur with the absence of before. Perhaps time crystallized from heat. Perhaps a prior cycle folded and yielded to a new dawn. Perhaps the river of moments springs from its own loop. Inflation smoothed the newborn sky, stretching quantum seeds into the scaffolding of galaxies, while forces parted and matter cooled enough to remember its name. When the fog subsided after 380,000 years, atoms formed and light slipped free. Leaving the cosmic microwave background as a lullaby we can still hear from every direction. Those faint ripples are not myth. They are maps, measurements, memory of a universe learning to speak. Through them we test our boldest ideas about spacetime, whether it is woven from continuity or from quantum threads that flicker beneath thought. And within this vastness, we find our reflection, star matter listening to its own echo. The lesson is gentle and immense, that wonder is a method, patience is a telescope, and humility is the only compass that holds true in a sky without edges.